Hello, everyone. So we're going to do another example. We're dealing with lines in three-dimensional space in this case. And so there's two problems here. And in both problems, we're given some conditions and we want to find lines that satisfy those conditions, okay? So we're just finding a line for which the things that they're saying are true. I'm just going to write them as vector functions. I'll leave the symmetric part uh, up to you, but let's just find the vector functions for these lines. So the first set of conditions, oh, and I've written the vector, one way to write a vector equation of a line, R of t is equal to R naught plus TV. R naught, remember, is a vector pointing at any point on the line. And then V is the direction the line is traveling in. And again, neither of these is really unique. In the sense that like R naught can be any point on the line. So the same line can be described using different points on it. And V, any scalar multiple of V other than 0 will also work. If you find one V, there's an infinite number. You can make it longer or shorter or even reverse direction. We're still describing the same line. So our first set of conditions is through the origin and the point 1, 2, 3. So if that was my origin, here's the point. So there's my origin 0, 0, 0. I'm not drawing the axes because this gets messy quickly. This gives me everything I need already because what do we need to write the equation of the line? We need to know one point on it. I've got two of them here because the line's going to go, let me draw this in. We want the line going through these 2 points. So both of these have to be points on the line. And it's easy enough to get the direction, a direction vector, by taking the vector between these two lines, which is really easy as well. I'll call this V. This is going to be the vector from the origin to this point, right? You might go the other way and then they'd all be negative. It doesn't really matter. It's still the same line. And so my equation very quickly can be written as, I'm going to take R naught, right, a vector pointing at a point on this line. I'm going to take the simplest one I can. This is the vector, it's the 0 vector that just points at the origin, right? Points is a little weird when you've got a 0 vector, but it works. And then t times this vector v. We can simplify this whole thing. There's a few different ways we can write it. We could write it as t, 2t, 3t, right? And so every point on this line can be described or pointed at for different values of t. When t is 0, it's pointing at the origin. When t is 1, it's pointing at this other line we have. When t is 1/2, it's pointing at a line halfway in between them. When t is -1/3, it's pointing at some point over there, and so on and so forth. So there's our vector equation of that line, okay? Right, it satisfies both conditions. It's through the origin and this point, and that's the only line that does that. All right, the second set of conditions, so a new line, is going to be through this point 2, 1, 0, and perpendicular to these two vectors that are given. So let's start with what I started with over there before, right? I already have R naught, right? I need a vector pointing at a point, and I've got a point. So I can take R naught to be, right? Again, it's not the point 2, 1, 0. It's a vector pointing at the point 2, 1, 0. The direction is going to come from the second part of this statement, perpendicular to I plus j and k plus j. So let's start by writing out what I plus j are. This is 1, 0, 0 plus 0, 1, 0, or 1, 1, 0. And then k plus j is 0, 0, 1 plus 0, 1, 0, or 0, 1, 1. Okay, so this was a vector and this is a vector, but I've written them both in component form, which I think is an easier way to do what comes next. So we want our line to be perpendicular to both of these. This should set off alarm bells to us that we're thinking about a cross product, that we're going to take the cross product of, let's just name these, A and B. We're going to take A cross B. So there's my two vectors. I just do my cross product. We'll get 1 minus 0, 0 minus 1, and 1 minus 0 again. So we get this vector 1, negative 1, 1. Okay. This is our V. It gives us the direction that's perpendicular to both of these vectors. Okay. And now we have everything we need to write our equation. R of t is going to be 2, 1, 0 plus t times 1, negative 1, 1. Or we could write this as 2 plus t, 1 minus t, t, combining those two together and multiplying the t inside. Either one's appropriate. And then you can go from this to writing symmetric equations, but I'm going to leave that for the viewer. Okay, that is, well, just to be clear, this is a line that goes through this point. Well, the point that this vector is pointing at, this point here, and it is perpendicular to the two vectors that are given. All right, thanks everybody. I will see you next time.